Yeah, we're live. What's up, everyone? I'm the Coach Shaver here to show you some RxJs magic. I shave off complexity so you don't have to. Everything is live, no cuts, none of that. Just you see it as it is. And let me just switch to the actual scene. There we are. Okay, beautiful. So what we're going to do today is we're going to create the Mac dock effect, if you will. So its basic idea is that we sort of click and it starts to sort of do that bouncing effect. You know it. If you ever use the Mac, I'm sure you know it. So I did some setup. I did some of the data bindings and sort of event handling. Don't worry too much about that. I wanted to keep it a little bit framework agnostic, so we'll just focus on sort of the core RxJS part, and then the data bindings are pretty straightforward. So I'll be live coding the whole thing, except for one little piece of code later on that I will take from my GitHub because it's just way too complicated to live code. But the rest will be done all live. So let's start. So with off, yeah, what do we have? Basic idea is that we have, this is kind of a sort of an observable creation function. What it does, it's just one of many where you can quickly create an observable to play around with and to sort of get a basic gist. So the off observable is sort of nice because it really quickly allows you to see if all your data bindings work, especially if you're working with movement. So bouncing gets subscribed here, and don't worry too much about this, but in the end it gets mapped to this sort of pixel values, right? And we all understand pixel values. So if I give it like 100, then it sort of goes up 100. And all the others as well. So let me just change one thing, and that's just to do start with here. Don't worry too much about what it does. It's just there to sort of trigger the observable emission once, so that every time we sort of change something, it gets updated right away, right? If I do 500 here, 500, then we are right there. So that's really good. Okay, so the way I like to always start is to really think about what's my source, what's my source observable? What emissions do I need? Obviously, I don't need off because, we want to animate, and off only gives us one value, but it kind of helps me to really explain a little bit what actual animation is, because the way we can think of animation is it's frames over time. So if we just pretend a little bit here, we start at 0 and then we maybe move to, 50 or something like that. And then we move back to 0, and it's sort of, that's kind of what we want to go for. And another observer creation function is called interval. And interval actually emits values over an interval. So it sort of keeps emitting endlessly, infinite, so to say. And that's good because that's kind of what we need, and we can pass it the animation frame scheduler as a second argument. So why do we need that? Well, so the 0 part of it, the one over here, kind of determines that we want to fire as quickly as possible, okay? We want to fire as quickly as possible. But why do we need the animation frame scheduler? Well, we want to fire when the browser has a frame for us. That's how you should see it. The animation frame scheduler is an API created through JavaScript that allows us to say, okay, at this moment of that famous event loop, we have some frame available for you. Here you go, there you go, and another one, and another one. So let's first just kind of see how that looks like. So there we are. And you might be wondering at this point, it's like, okay, well, maybe you have a really fast computer and I don't. Is that a problem? Well, yes, it's a thing, and we are going to address it. But let's first talk about this sort of conceptually, what we would call this. So what we are doing is we fire deterministic frames. So actually I said it wrong there, is non-deterministic frames, right? Because our frames do not have a consistent value over time. At second 1, I don't know exactly what the value will be, because maybe on your computer it will be more or less or something like that. So we'll work on that later on. It's kind of a complicated concept, so I want to ease towards that. You know, it's kind of important in this series that we work towards the solution and not just get right to the solution and sort of don't go through the proper iterations. You know, it's important, especially with functional composition, that we kind of compose slowly towards the solution instead of sort of dumping all the knowledge on you and then you'll just be lost. You know, we'll start to work from what we know. So what we know right now is that we're firing as fast as possible a bunch of frames, and we see where that sort of led to. It leads to this animation, and that's not what we want, obviously, because we want it to bounce. And we can do that by just taking the math object in JavaScript and take the sign and put the X in. So now we have sort of this continuous, endless up and down motion through sine. And the way how sine works, and let me just exaggerate sine a little bit by giving it a little bit more like that, and also slowing it down, if you will, by taking whatever comes from the interval and dividing it. So there we are. And also we can do +1. I actually have to wrap this in parentheses. So there we are. So the reason why we do the +1, let me see, sorry, I should have done it here. There we are. There we are, sorry. There we are. So the reason why we do +1 is because sinus always returns us a value between -1 and 1. That's sort of how sinus works. So sinus is actually not that hard to understand. The way you should see it is if you think of a triangle, and there we are. There we are. That's sinus and cosinus as well are there to calculate these legs, you know? And you can understand that as the degrees change, the legs become either long and all the way minus. So we sort of turn around and then we get this up and down motion, or left and right, if you will. You can kind of map it to, obviously, the y value in this case of the thing. So that's sinus. So now we have sort of taken this idea of infinity and we made it sort of more predictable and understandable, and we used a little bit of math for that. So that's pretty good. So let's just change a little bit of the values to make it more pleasing. So let's see, we can say that we want 10, maybe a little bit too fast. I don't know, that sounds about right. I think we need to do a little bit of something. I remember that this just makes it a little bit better, yeah, because we have a little bit of an offset at the beginning. So there we are. This is sort of the basis, right? So we have this frame thing that keeps on firing, and you can understand that those values become quite high. So we slow those values down. We're not slowing down the speed of emission, you know? This is important to understand generally with RxJS, is that you have to really think multi-dimensional. We are talking here about height. We're talking here about time as well. So we are mapping the idea of time into height. You know, that's what we're doing. We're taking, conceptually, we are starting with time in a non-deterministic way, as fast as you can give it to us, you know, and we are mapping that to height. And the only reason we're now satisfied is because we're in this closed loop of my computer and we're happy how it looks like, but that's not the way we want to do it. You know, we are great developers, so we want to make it work for everyone. At second one, we want the animation to always be at that moment in height. Does that make sense? That moment in height. Anyway, we want it to be at that sort of specific height or whatever. So that is conceptually a quite difficult thing to understand. So let me just write up a little bit of code and then I'll later explain it, because this one is just kind of complex. So we'll take whatever was here and we'll kind of, okay. So nothing happened, technically, okay? This is a good starting point. So we wrapped interval into defer. We wrapped this creation, observable creation function into another observable creation function called defer. The only difference that defer has is that we have some space to define stuff here. You know, we can define things. And what that allows us to do is, because defer is also an observable, we know that observables only emit values as soon as they are subscribed to. And that, in the case of defer, means that this gets evaluated the moment it gets subscribed to. So why is that important? Because in order to change this from a non-deterministic fire as quick as you want kind of thing, we want to create predictable values here, okay? So this x currently is not predictable. And the way we can do that is by looking at, so let's, I don't know, call this determiner or something like that. So this is the determiner, and we say date that now. Okay, so the current date, the current time, and we just put in another map. And currently, this is interesting, we're not interested in the value of x that came from the frames, because we are going to sort of create our own values. So what we can say is that we want the current time, and we want to subtract it from the time that we started, from the determiner, okay? And I think that currently the determiner is not a great name anymore. It's kind of like time since we started, okay? That makes more sense. There we are. So you can see that it leads a little bit to different results, so we kind of need to fiddle around with this a little bit, change some of its values, maybe put it to, I don't know, 80, what is good? Yeah, that seems about right. But what we now effectively done is that we are not relying on the value of the emission of the interval, we're just relying on whatever frame rate it basically gives us. So however fast it is. Whenever a frame fires, we are then turning it in to something predictable. So you can understand that when it first starts out, it's 0, and it sort of works its way as time progresses, okay? So conceptually, this is time, and then conceptually, this is degrees, you know? This is circulation. As we saw with the triangle before, it's kind of, you know, at 90 degrees, I expect this sign, and so on, and at 180, 360, 720, all the way through, you know, endlessly. So that's good, that's good. Okay, so that's the basis. Let me just remove this comment because we got that. What we want now is we want to think about when should this thing end? Okay, when should it end? And there are these sort of completion, you know, when the observable is completed. So we got take while to say, you know, so we can pass it something. We can say like, okay, we want the value to be this, you know, we want it to be so many pixels, that many pixels, or whatever, you know, we know that we are going up 40 pixels times 2 maximally. So we know that we are maximally at 80 because metsign returns us a value between -1 and 1. We're doing +1, so maximum 2 makes 80 pixels. So we could definitely say that we say, okay, well, let's think about it conceptually as P for pixels. We say take while pixels is lower than 80. You know, we could say that. Of course, it actually never gets to that, so let's say 79 there. There we go. So that's take while, and then it completes, you know, and then when we take out this start with, we can actually do it on the click. So that works. Okay, So now we understand kind of what take while does. It sort of waits for a certain value to come and say like, hey, you are done, okay? The problem, however, with this obviously is that the value that we get is kind of like 80, and then we have one cycle, and that's not enough, or not even a full cycle, half a cycle. So what we want to do is we want to transform the value to also include cycles. You know, we basically want an object. You know, we want an object where we say that we have, let's say, the height. You know, so this could be height. That's sort of the end thing. Let's say height, which we know maximally is like, I don't know, 80 pixels, and we want it to have something like cycles or rotations, or I don't know, just anything. And we say like, okay, we want 6 rotations. You know, we want 6 times for you to have been up and down, kind of thing, because we can calculate that. You know, we can actually take whenever it's all the way up and whenever it goes down, and sort of we can calculate that. And the way we can do that is with an operator called scan. And what scan does is, I like to think about it when you're going to a shop, you know, and they scan your groceries. So every time they scan your groceries, they add it to a list. Like, this was 5 euros, this was 10 euros or dollars or whatever you're from. Okay, so you scan it. You scan the values that come through your pipe each time, and then you do something with that. And in this case, every time we go through the pipe, we want to return an object where we take the height, that original idea, pass it to this thing, and we want to take rotations, because we want to use those rotations or cycles to talk to this take while and say, hey, when you're 6, stop it, you know? Because then we know that we're always at sort of the lowest point, the highest point, the lowest point, the highest point, that kind of stuff. Okay, so I'm not gonna write out the scan because it's, you know, it's quite complex, and I don't think it really would be possible for me to live code that right here, and also I don't really think that would really help us. So I'll just paste it in for now. So I'll quickly go over it. It's quite complex, but scan is basically made out of 3 sort of roughly parts. So you have these 2 first arguments. So this is actually the P. So that sort of IDs to previous, you know, previous. And then we have the C, which is sort of current. And I sort of made it current height, so CH. So that's a number right there. And CH is always the first one to come in, and the previous value gets initiated in this object over here. And this can be an object, an array. And if you know reduce on the array, this is really similar. The only difference is that this sort of builds out over time. So scan, just like the grocery shopping, it gets sort of bleeped in, and you get a accumulation over time. So that's scan. Scan is a very, very important operator. It's basically state management. You know, you're sort of getting state in, you combine it with something previous, you return something new. That's kind of the idea, and that's exactly what we're doing here. So I won't go too much into sort of the body, because I see that very much as an implementation detail, and I wrote it down quite messy, and it's not really the point. The basic idea conceptually is just that what it does is it returns the height, just as before. So we got that here. So let's just actually start by, we'll just comment out the take while for now, and we can see that we actually already got the object. So that's really great typing there. And we know right now that we have the H and the R. So we can actually destructure that to only have the H, because in the end, we're only interested in the height. And again, just to get sort of to the basic idea, so we did it on the click now, you can see that that works, but it never stops. But we are accumulating that other value, you know, the R. And to show that, let's just do a tab. There we are. So if you write down the tab like this is great. You do lose your typing, by the way. So if you look in here, you see that it sort of defaults to any. If you want to keep that, it's a common mistake, just write it out, and then you keep your typing. Okay, so now we got our typing. So let's that went wrong. There you are. All right, so let's look at the console. Okay, so we'll just take this object. So we see that we do have that object, right? We do have the height, 27 pixels high, and the R, which is the amount of cycles. So each cycle is basically up, down, and then we get one cycle added. And that's sort of what the body of this function does. So that means that we can use take while, and take while just expects you to have some Boolean expression, you know, so we can actually take that one and also take the R in this time. And we say that we want the R to be, let's say, six sort of half cycles. So that would be three times in total, right? Let's take out this console. A little click here. So 1, 2, 3, stop. 1, 2, 3, stop. There we are. So we can definitely do 12 or something like that. There we are. And that's pretty good. That's kind of what we want. So we have fully dynamic, you know, we can change values around, make it really fast, make it sort of slow. By the way, we also have it protected against double clicks and things like that. Actually, do we? Okay, it was a little bit buggy there, but it does work. So we are there. And then we also, of course, have the ability to make it sort of the amplitude higher of the sine wave. There we are. So it's completely nice. Okay, so that sort of concludes this video, but there is something inherently very, very wrong with this, you know? But I want to make that mistake on purpose, and in the next video, I want to solve that. And that requires us to rewrite some of this, you know, to rewrite some of the basic foundations of what we're doing. And I think that's really great, because RxJS is hard enough in and of itself, but one of the even more harder things is to rewrite stuff, you know, and that's kind of what you do. So let me bring back the sort of the end of it, you know, there we are. So yeah, so that's kind of what we're gonna do in the next video, right? We're gonna look at it. We're gonna try to make it even better, make it more resilient, make it more scalable, and address some of the issues, and one of the issues that we kind of introduced ourselves. I'm curious if you know what it is, and I hope to see you in the next video and do all that YouTube-y stuff, subscribe, comments, and all those things. You know where to find them. So see you in the next one. Bye.